Okay, so this is the second part. We're going to look at two different questions today. And yesterday we considered a scenario where a projectile is fired from a location, goes up, and it comes down, where basically, if you think about the vertical displacement, it ends up being zero. Because vertically, at the end, it ends up going to the same position. But now we're going to consider a different scenario where we have a projectile fired here, it goes up, and then it comes down, and you can see that where it ends up is not the same vertical position. So we're going to look at this scenario. Now, first off, what I'm going to do is and we have like the speed, so we're told that the projectile is 100 meters per second, the angle is 30 degrees, and this is some sort of a cliff, that's 200 meters in the air. So, we talked about yesterday that if you want to know how far the projectile goes, you need to know how long it stays in the air. So, first thing we're going to do is we're going to figure out, well, how long is this thing stay in the air? So, we're going to figure out the time. So, we're going to look at how long does it take to go up. I'm going to start with that one first, okay? But before we figure out that, let's actually break down this projectile into its x and y. So this y component would be a function of sine 30 times 100, and the x component would be a function of, because this is the adjacent side, cosine 30 times 100. So this is 50, and this is about 87. Okay? So we have a vertical component of 50 up, and we have a horizontal component of 87 to the right. So we're going to figure out the time to go up. Now, we're going to use the acceleration formula again. So if you remember, the acceleration formula is t equals bf minus bi over a. Now, at the top, now this is the vertical speed, okay? Remember the horizontal speed doesn't change. So actually, what we're talking about here is we're talking about the vertical speed. So at the top, what's the final vertical speed? 0. Very good. What's the initial horizontal speed? 50. This is going up. Up is vertical. What's the acceleration due to gravity? Negative 9.8. Alright, so how long does it take to go up? It looks like it's about 5.1 seconds around there. Rafty, what is it? 5.1. Now, yesterday we said, if it's like a perfect parabola where there's no vertical displacement, time to go up and time to go down should be the same. But you can see here that it shouldn't be the same because it's not perfect. You can't just slice it in half and it's perfectly symmetrical, right? So now we're going to figure out the time to go down. Yeah, very similar to that test question. So the time to go down, well, what we can do is we got to figure out the distance we went up. Then we can figure out the time to go down. So let's start with that. What's that distance up? Well, it wouldn't be, again, the average velocity in the y direction times the time to go up. Now, the average velocity in the y direction is, well, it starts at 50, goes to 0. So what's the average between 50 and 0 is 25. And then the time to go up was 5.1. So that should be, I believe it's 127.5 meters. So now the question is, okay, if this projectile went up another 127.5 meters, how much does it fall then? So if I said distance down, yeah, so it should be 200 plus 127.5, which is 327.5. what's the initial speed going down from the top? 0, right? And we know the acceleration due to gravity is negative 9.8. So remember, we could use this equation to figure out time. So here's the thing. This is the distance down, so this actually should be a negative value, but they're going to cancel out. So the time to go down is a function of the square root of 2d over a. So let's figure out how long it takes to go down. 2 times the distance down, negative 327.5 over negative 9.8. So what's the, so it looks like it's about the square root of about 660 over 10, rounding it off. Like the square root of 66 around there. 8.2? 8.2 seconds. Okay, so how long is this thing in the air for then? Well, it went up and took 5.1 seconds to go up. And it took 8.2 seconds to go down. So then it makes sense that the total time is what? Yeah, so the total time would have to be 5.1 plus 8.2, which is 13.3 seconds. Okay, so it's in the air for 13.3 seconds, right? Hold on. So then, if it's in the air for 13.3 seconds, it's also moving horizontally. So if I said to you, what's the horizontal distance? It's just simply a function of the horizontal speed times the total time in the air. The horizontal speed, if you remember, was 87. So it's going to be 87 times 13.3, which is, what? What is it? 87 times 13.3. There's no acceleration along the horizontal. So what's the horizontal displacement or the range? Yep. 1,000. That's fine. We'll leave it at that. Alright. So there's our final answer. So again, a couple of concepts. One is if you want to know the max height. If you want to know the height, do you need the total time or do you need the time to go up? Time to go up. But if you want the range, like how far it goes, you need the total time. Those are two very important concepts, okay? When you're looking for the distance up, you can use the average speed up. But when you're looking for the range, the horizontal speed doesn't change. So we don't use the average in that case. Now, there are actually two other questions here. One is, what is the speed at the max height, and what is the speed at the moment of impact, okay? So I'm going to quickly take a look at those two. So I'm actually going to see if I can squeeze that answer in right here. Let me give myself a bit more room, see if I can squeeze it in right here. Okay, so I'm going to see if I can squeeze in D here, okay? Now, the first one's easy. At the top. What's the vertical speed at the top? Yeah, 0. What's the horizontal speed at the top? 87. So then my answer is 87. At the top, think of it as a vector, right? You know how we did vector addition? Well, can I add 0 and 87? Yeah, I can. It's going to give me 87. Because there is no vertical component, right? So that means the only vector is really, the only thing is it's horizontal, and it's 87. So at the top, the vertical speed is 0. So it only has horizontal speed. So that means my speed is 87. But at the bottom though, so this is at the top. Okay, this is at the top. But at the bottom, it's a little bit different. Okay, at the bottom, the horizontal speed is still 87, but the vertical speed is not 87. It's different, right? So what exactly would it be? Well, do we know how long it was in air for? Okay, so let's see if we can figure it out. Now, that vertical speed would be the final vertical speed, right? It's the speed at the end. So it's actually the final vertical speed. So how do you figure out final speed of an object if you know its time? Yeah, so what was the time again in there? 13.1 seconds. And you know its initial speed up. Okay, 13.3. You know its initial speed up is 50. And you know the acceleration due to gravity is negative 9.8. How do you figure out final speed? Or can we just not use the acceleration formula? The final speed is the initial speed plus AT. That's the acceleration formula. VF equals VI plus AT. Right? Now we can solve for VF because our initial speed is 50 and our acceleration is negative 9.8 and our time is 13.3. So what's our final vertical speed? Negative 80.3. Okay. So now we have so the horizontal speed number doesn't change, right? So it's 87. So that's 87. And at the end, the vertical speed is negative 80. Right. So I'm going to finish the answer off over here, okay? So at the bottom, Vx is 87. Vy at the bottom is negative 80.3. So if I had to draw this as a vector, what would it look like? Well, it would look like this. It would be 87 this way, and it would be 80.3 this way. So then how would you figure out the speed? Yeah, you would just figure out what that component is, right? So, the actual speed of the projectile. So you know how initially we had the speed of the projectile, and what did we do? We broke it down into its components. Now we do the opposite. We have the horizontal speed, which is fixed. We have the vertical speed now at the bottom, but those are components. So now we put them back together, and you get the actual speed, which is 118.4. So you could figure out the speed at any point. You have to just remember two things. One, remember the horizontal is fixed, but the vertical does change. But you could use the acceleration formula to figure out what that vertical component is. And then you just put it back together. Yeah, at the bottom. A lot of people think it's 0. I mean, eventually it will be 0 because it does come to a stop. But at the moment of impact, that's what its speed is. In this case. Okay. We have one more question. Pause it? Sure.